In the ancient Chinese textbook, the Mathematical Classic of Sunzi, there is a very famous problem called chickens and rabbits in the same cage. It goes like this. There are chickens and rabbits in the same cage. Altogether, there are 35 heads and 94 legs. How many chickens and how many rabbits are there? We can very easily model this problem using a system of two linear equations with two variables. Let's say the number of chickens is x1, the number of rabbits is x2. The total number of animals is 35, so we have the equation x1 plus x2 equals 35. Chickens have 2 legs, rabbits have 4. Altogether, they make 94 legs. They give us another equation, 2 times x1 plus 4 times x2 equals 94. Together, they form a linear system of equations. Solving this system is actually pretty straightforward. Take the second equation, divide both ends by 2. You'll get x1 plus 2 times x2 equals 47. Now subtract the first equation, x1 plus x2 equals 35, from this new one to eliminate x1. This gives you x2 equals 12. Plug that back to x1 plus x2 equals 35, and you find x1 equals 23. So there are 23 chickens and 12 rabbits in the cage. Let's visualize this chickens and rabbits problem geometrically. Each linear equation represents a straight line on the coordinate plane. The red line represents x1 plus x2 equals 35, meaning every point on that line satisfies the equation. The blue line represents 2 times x1 plus 4 times x2 equals 94. The intersection of the red and blue lines is the solution to the system. If you draw the vertical line x1 equals 23, that tells you the number of chickens. And the horizontal line x2 equals 12 tells you the number of rabbits. The point where the vertical and horizontal lines meet is also the solution to the problem. We also express this problem using matrix multiplication. The equation x1 plus x2 equals 35 becomes the first row of matrix multiplication, and 2 times x1 plus 4 times x2 equals 94 becomes the second row. Together, we can write this as matrix A times vector x equals vector B. Here, vector x is a column vector of unknowns, and matrix A is a square invertible matrix. Once we compute the inverse of matrix A, solving for vector x is easy. Now let's look at the equation matrix A times vector x equals vector B from the perspective of linear combinations. Break the matrix A into column vectors. The first column vector A1 represents a chicken. It has 1 head, 2 legs. The second column vector A2 represents a rabbit. It has 1 head, but 4 legs. So A times x gives vector B is really saying x1 times vector A1 plus x2 times vector A2 equals vector B. In other words, the vector B is a linear combination of vectors A1 and A2. To make the visualization easier, let's change the values in vector B. From the perspective of vector space, the bases A1, A2 span a 2D plane, and clearly, vector B lies in that plane. And x1, x2 are simply the coordinates of vector B in the basis of A1 and A2.